Hey there everyone, and welcome. Thanks for joining today's SunLink University webinar. Today's topic is managing the unexpected, anticipating, and adapting to installation unknowns. I'll begin by introducing the team you're going to be hearing from today. My name is Nick Troya. I'm the Director of Project Management here at SunLink. Here with me today are my colleagues, Sarah Jacobs, Mechanical Design Engineer, and Keith Beisner, our Field Services Senior Manager. As we talk today, we're going to be covering the topics you see in front of you. We'll start by discussing the project realities and some market trends. We'll then transition into the lessons learned from our Field Services and Install team. After that, we'll go over the product solutions from our engineering and design team. And then we're going to close it out with a brief Q&A. Please feel free to ask any of your questions in the Q&A portion throughout the entire presentation. We will follow up with as many questions as we can when we get to the Q&A portion at the end. First, we'll go through project realities and some of the market trends that we are seeing today. As an industry, we're all seeing this continuing trend of tackling more projects with difficult site environments. Some of the reasoning behind this is actually quite positive. As the solar industry in and of itself continues to expand, the development of solar projects has become more attractive. We've seen this create the inevitable attempt for many to put solar in areas even a few years ago that we might have seen as less desirable. The positive of this, of course, is we see more work and more solar in the market. The challenges around this require the wherewithal to design and work around poor terrain, and of course, those less than optimal soil conditions that we all know and love. Now, these are just a couple of examples, but for the focus of today, we're going to focus on these two examples to kind of go over these slides in this presentation. Even with these added challenges, the timeline for completing projects, as we've all noticed over the past few years, has continued to shrink drastically. Installation timelines, as most of you know, have been cut in half or nearly in half in the last 3 years. Much of this change is because of better racking and growth and experience in the industry as a whole. Of course, this means we are now working faster than ever before, leading to less time for us to evaluate for problems beforehand, and more specifically, less time to react to the inevitable challenges that we all know we're going to come up with during the installation process. This means less time to process change orders, less time to wait for those change orders to be fulfilled, and the worst part of it all, less time for the material to get to the site and crews that need them. As solar becomes more accepted as a valuable investment, there has been, as one would expect, a natural easing and due diligence. This easing has allowed, and in some cases forced, more maturity and knowledgeable growth from everyone in the design and development landscape. Continuing on this line, there's also been a noticeable trend to minimize site prep and an obvious attempt to reduce costs. To account for this, installers want the added flexibility in the racking design to make up for terrain variances. We're going to focus on that term flexibility as we continue to move on throughout the presentation. Another shift that has been happening has been in the broad perception of the industry as a whole. Solar continues to seem like it's moving from being a tucked out of sight asset into, in many circumstances, a prized public possession. This is increasing the attention paid to the look of the final product, and this increased attention is creating what we see as an opportunity to provide increased flexibility and adjustability within our systems in an effort to react to the difficult terrain that we've been discussing. Now, racking manufacturers have historically designed their systems to allow for what is deemed a typical job site. Now, setting aside the greater discussion of what typical actually is, we want to ask the question, why was this actually done? Well, the goal here was actually to reduce the costs passed to the customer. And although, of course, this was done with the best of intentions, what this has actually done in many instances is create an inability to accommodate unknown variables in more extreme cases, and in turn, actually increase the time and costs in difficult projects. Then, unfortunately, it's left installers requiring new parts and delays in designs and dealing with, again, change orders. The difficulties then have had an opposite effect on installers trying to solve problems on the fly and increase the annoyance of slow change orders and an inability of the systems to truly adapt to what's going on in the field. Finally, as the customer base has become more sophisticated and project portfolios have gotten larger, there has become both a desire and a need to standardize products across all types of projects. This harkens back again to the term flexibility. The final need then becomes consistency across the major areas of mechanical, electrical, civil designs, and layouts. This will enable everyone with a much more efficient front-end planning process and a cleaner installation, driving economies of scale while solving these unique site challenges. And as these trends have shown, solar market as a whole continues to garner a better understanding of capacity generation, which has and will continue to increase the range of available products that we will get and allow us to get what is the most possible out of these projects. Now I'll hand it off to Keith, who's going to provide you some insight from our field perspective.
Thanks, Nick. We can now correlate what we see in the market with what our PowerCare team experiences on actual job sites. As you mentioned, demand for standardization is high. We see the levelized cost of energy decrease and on-site installation efficiency increase when the same system can be used on every job site. Standardization also allows for proactive solutions when unexpected circumstances are encountered. We'll go through several examples over the next few slides. The first lesson the PowerCare team has learned is that short tables are very versatile and can accommodate changing terrain and variable site conditions. We all know that construction sites can be busy and crowded with lots of moving machinery and associates. Materials for short tables are easy to handle and maneuver around a job site, and components such as structural purlin splices are reduced. In addition, short racks are easily adjusted, thus increasing efficiency and maintaining aesthetics on high visibility job sites. Taking this lesson one step further, many developers and customers now look for standardized mechanical and electrical designs to lower costs and increase efficiency when working on multiple projects and in multiple locations. An optional third foundation for the ground mount system allows for standardization by accommodating changes in environmental factors with the same size table. The table size and components stay the same across all project sites, no longer requiring separate electrical and mechanical layouts at each design stage and allowing for easy preparation, installation, and O&M. The third foundation post also potentially reduces foundation loads, allowing for versatile foundation design and in some cases increased foundation installation tolerances. Over the last several years, we've also seen projects move more and more into undulating or hilly terrain. The ability of standardized tables to accommodate slopes and rolling terrain not only improves mechanical installation efficiency, but also significantly reduces civil work. Civil work, as we all know, is time-consuming, it's expensive, and in some cases it can actually complicate site conditions with improper compaction or loose surface soils and debris. Standardized tables also increase land use efficiency. We are now able to generate relatively more power on a given site by installing with existing conditions instead of avoiding slopes and hills. Land utilization also increases on uniquely shaped sites by fitting tables in the small corners and small portions of the area, all with the exact same table design. By reducing the civil work and increasing land use efficiency, standardized tables are able to reduce the overall levelized cost of energy for each project. In addition to installing on variable terrain, we see the need for versatile foundation solutions for variable subsurface conditions. Looking at the four images on the right, we see four different soil conditions, all on the same 4 megawatt job. Soil conditions here range from stiff clay to a soft clay with cobbles to silty sand with caliche. The foundation design needed to accommodate all of these conditions as well as potential mitigation work with the caliche. So during pre-construction pole testing, our PowerCare crews commonly see multiple soil conditions that would affect the foundation design. Loose conditions can be caused by variable topsoil depth, disturbed or eroded soil, and drainage systems. Rock is consistently found in the northeast, while caliche is encountered in the southwest. Similarly, cobbles and boulders are frequently encountered in glacial till in the northeast, as well as in colluvium and commonly encountered in the west. Even when soils are consistent, obstructions in respective depths cannot be accurately predicted. One obstruction on a commercial site can carry significant costs and time for mitigation. Similarly, frequent refusals on a large job site will have a significant impact on installation cost and overall progress. For example, in the image on the left, you see one boulder encountered by our power care team on an otherwise clear site. But this one boulder required additional machinery and affected the construction of multiple racks. The top right image shows an attempt to drill into the subsurface for a concrete footing after refusal. As is common in the desert Southwest, the surface is compact, but underlying soil is loose, easily caved, and filled with voids from displaced cobbles and boulders. So how do we deal with these common situations? These images show the typical reactive strategies for mitigating these types of refusals on job sites. The image on the left shows an excavation for a concrete collar installation, while the image on the right shows attempted drilling. Both strategies are common on job sites because they are the easiest for installers to perform on the fly. However, both solutions are expensive, they both require extra machinery and significant time. They're both labor-intensive and they significantly slow installation progress. These examples illustrate the importance of a standardized, interchangeable components and foundations for proactive on-site mitigation work. Interchangeable foundations ease the burden on installers, creates more predictable pricing structures, and increases installation efficiency. So taking the market demand that Nick discussed, as well as the lessons learned by our power care teams on site, SunLink continues to develop innovative product and service solutions to ease solar installation and advance solar adoption. Sarah will now discuss these specific product solutions and how they are incorporated into system designs and installation.
Thanks, Keith. So now I'd like to talk about the product solutions that we're using to solve these issues that are encountered in the field. To start, here's an image of the module panels. These make up the top half of our fixed tilt ground mount system. These panels can be configured to any environment and can be used in combination with a variety of substructures depending on site conditions. This is kind of our base solution using 2-pile driven posts. As Nick mentioned, we've seen portfolios spread throughout a variety of regions, which requires us to design our system for a variety of environmental conditions. For example, this 2x9 table that you see here might be used for a project that's on the West Coast. But using this same 2-post design, we would need to shorten the tables in order to accommodate a project in the Northeast. By adding a third foundation in the center of these tables, we can use the same 2x9 table size for a project with these higher snow loads in the Northeast. This allows us to standardize tables across a variety of sites and simplifies the mechanical and electrical layouts across the portfolio. So using this same set of top panels, we can then provide solutions for a variety of different soil conditions. So as you can see here, we have a table that uses either ground screws or helical foundations. The ground screws we would use in cases where we encounter bedrock at shallow depths. We could use this solution only on certain portions of the site. And helicals, which we'd use in cases where we encounter loose soil. This could be a swap-in solution on just a couple foundations on a site. So again, we're able to provide another foundation option using the same set of top components. So in this case, we have a cast-in-place ballast foundation. Typically, you'd find that you'd use this solution on landfills or brownfields, but we can also use this as a swap-in solution on site. So as you see here, this table has one pile-driven post and a swapped-in set of ballasted foundations. We could use this in cases where we encounter pile refusals on boulders or bedrock. As you can see, the top view is consistent throughout all these different types of configurations. So you can swap in different foundations without altering the overall layout. Again, from this image, you can see that switching out these foundations doesn't really alter the overall aesthetics. Since you're using the same set of components for the top panels, really the tables look very similar across the site. So as projects are also moving faster to the installation stage, there's increased need for having additional flexibility in the system. if a last-minute module change is made, we're able to accommodate this change by this hole pattern that you see in this image here. So if a module's changed and the hole pattern on that module is different from the previous, you're able to swap, just move the location of where you're installing the panels on the system. So as you can see, using these two different modules, we're just able to accommodate that by using a different hole pattern. So this eliminates the need for any field drilling or sending new components to the job site at the last minute. Another issue we're seeing is that not all sites are level. So we're able to accommodate up to a 20% east-west terrain with the existing components in our system. So as you can see here, we're able to accommodate either a constant slope or rolling terrain up to this percentage. We can also swap in the other foundation options that we just went through earlier with the ones that you see here. So we can accommodate any of these different foundation options with a variety of slopes. Although we've seen a shift to portrait orientation due to the lower overall system costs, we're still able to accommodate other types of orientations. So either using modules in landscape if they're framed, or also accommodating frameless modules. We've talked a lot about the flexibility built into our product today, but we're continuing to work on new innovations based on feedback from the field. Our customers and SunLink's team of PowerCare installation professionals are our most valuable resource when designing the next generation of this solution. If you have thoughts about product features that would make your projects more successful, we want to hear about them. Our team looks forward to sharing future design evolutions with you. Thanks, and now I'll open it up to questions.
Okay, so it looks like we have a few questions that have come in today. We'll start with the first one. What are the common ways to troubleshoot refusals during installation? Keith, maybe you can take that one.
Sure, absolutely. When we're on job sites and we encounter refusals, first we kind of go through a checklist so that we report proper information and understand the current situation. So first we want to look at the depth achieved by the driven pile. That greatly affects what solution we're going to provide. If it's very shallow, the mitigation is going to be different than if a pile is driven very deep, and a lot of that has to do with how much we're going to disturb the soil. So after we know the depth of the refusal, we then want to review the geotechnical report that was provided for the site and the pull test report, just to ensure that piles have sufficient capacity. And then we go through our list of potential solutions. First we want to look at if the soil is going to be significantly disturbed or not by removing the pile. If the soil is going to be significantly disturbed, we typically look at cutting the post at grade, and we can use a swap-in cast-in-place foundation. If the depth is shallow, we can retest the post and actually just cut the pile, leaving it if it has sufficient capacity. If we encounter shallow rock, we can swap it with the ground screw, or we can swap it with a helical if there's little resistance during advancement and the pile is easily removed. So I think that covers about each situation.
Great. All right. Well, thank you, Keith, for that. That was very helpful. Next question we have in here, what are your experiences dealing with wind loads?
I think I can take this one.
Sure.
So we can handle various wind loads by adjusting the overall table size. So if we have higher wind loads, we can just use a slightly smaller table size. So as I was showing 2x9 panels, we can also accommodate higher wind loads by adding that third foundation in the center of the table.
Okay, great. We have another question here. With civil work reduced or eliminated, what surface cover is recommended for your ground mount systems? Keith, that might be a good question for you.
Yeah, so without any civil work, and obviously a lot of the sites we work on, they don't want to alter the terrain at all. They don't want to alter the surface. So we really just recommend leaving the native vegetation. And the main reason for this is erosion control. So when we look at short vegetation or short grasses, these are ideal because they're easily maintained. Other considerations that can be included, are surface materials that you can drive and maneuver machinery on. So again, vegetation kind of keeps the surface topsoil consistent, whereas if it's removed, it's easily eroded, and it creates very loose, poor conditions, especially if it rains. So if a cover is not used or if vegetation for some reason isn't present on the site, we just recommend proper compaction to maintain that surface soil structure.
Okay, great. Thank you, Keith. Next question that we have, can any of the table configurations shown in today's presentation be used in combination with each other?
Yeah. So in the cases that I showed where we have a ground screw or helical option, those could be swapped in with any of the other options, or if you had a 3-post table, you could also use the ground screw or ballasted on one or both of those footings. So since you're using the same components on the top of each table, we're able to swap in whichever option wherever we need to.
Great. Next question might also be a good one for you to take, Sarah. Can multiple modules be used on a site using the same mounting components?
Yeah, so as I showed in the image of the hole pattern on our post frame, you can use different modules on the same site because we're able to just shift the way that we mount those on the frame.
Okay, great. We have another one here. Are additional racking components needed to accommodate for steep terrain? Keith, that might be another one for you, or Nick, if you want to chime in on that one. Go ahead, Keith.
Okay. So yeah, additional components are not needed up to 20%, and that's in any direction, east, west, or north, south. Above that, as we get very steep above 20%, from an engineering standpoint, we look at it on a case-by-case basis. But our standard system on slopes up to 20%, no additional components are necessary.
All right. I think we have time for maybe one or two more questions. Next one here, does SunLink perform the load testing?
Yeah, this is Keith. I'll take that one again. We do. Our power care team provides pre-construction pole testing and geotechnical investigations. That includes testing for the foundations themselves, as well as corrosion analysis related to the foundation design. And we provide that for any project size and any location.
Okay, great. Thank you, Keith. I think we have time for perhaps one last question. Do you have vertical adjustments built into your racking?
Yes, this is Nick here. So we do have vertical adjustability, a couple of inches built into the standard system on its own. That can accommodate variances such as trying to get, edge to edge of the table to line up better, or just to handle the most, the simplest of terrain out there. And then when we get into those extreme examples that we've noted, we do have the ability as far as additional components, things like that, that can adjust for even the most extreme circumstances. And that can be designed and planned ahead so that it's actually built and designed into the racking that you need.
Okay. We're going to actually do one last question here, and then I think that will probably wrap up the half hour. Question was regarding what is our international footprint throughout Latin America, and specifically where do we have support, et cetera. So I'll go ahead and answer that one. Basically, we have done some projects in Latin America, most recently in Honduras, and actually our CEO and a few of our VPs are in Mexico City right now as we speak. And if you have some projects that you're interested in, you can reach out to our sales team. We're actually going to put up the email address and phone number after this, and so feel free to either reach out to your current account executive, or if this is your first time, go ahead and reach out to our sales team, and we can follow up with you from there.
Thanks, George. All right, well, that ends the Q&A session. Continuing on to close out here, I want to remind everybody that as part of what SunLink provides, we also provide hands-on training with all of our systems at our warehouse and training center in San Leandro, California. We do this on a weekly basis. We have customers coming in to train, to look at our systems, work with them, You know, at times we'll do an entire day of training, looking through specific project details, et cetera, and we can set that up. Feel free to reach out if you have any questions regarding this or anything else. And then continuing on that, we'd like to thank everyone for sitting in and listening to us today and providing us the questions you had. Sorry we couldn't get to every question that came in, but please feel free to ask your question through the notes here at webinar@sunlink.com or any other questions that arise after this presentation. And also feel free to reach out to us at the contact information here, sales@sunlink.com, and then the phone number that's provided. Appreciate it, and everyone have a great day.